Okay, so today we're going to be talking about segments and their measure. And in order to do this, the first thing we need to really talk about is we need to talk about distance, okay? So distance, anytime you're thinking or talking about distance, you want to know that distance is how far you travel. Hopefully this summer you guys are traveling somewhere, whether you're going to your friend's house down the street, you've traveled a distance. So when we think about distance as how far you travel, we need to know that means that it's always positive. Even if you walk backwards, you've traveled a certain distance. Watch, if I move backwards, I'm going to have traveled at least a foot maybe when I take that walk. So, all right, so let's look at this segment I gave you. I gave you a segment, and if you could go ahead and put the point x above coordinate negative 3, p above negative 1, y above 0, and z above 5, and we're going to ask you the question, what is PZ? Now, I didn't ask what is segment PZ. I just gave you the letters PZ. That means that I'm asking you for the distance. All right, so I could just look at it and count 1, 2, 3, 4, 5, 6, right? And I know that PZ is 6. But is there a way I could have done that if the numbers were bigger? Well, let's think about that. If I wanted to find PZ and it's 6, well, if this is 5 and this is negative 1, could I have done 5 minus negative 1? So 5 minus negative 1 would have become 5 plus 1, which is equal to 6. Okay, so that's one way to find your distance. But we have to remember, since distance is always positive, we're really always taking the absolute value. Absolute value will always give me something that's positive, right? So when you're doing that, remember, we're always looking for the absolute value. But if you really want to, you can take the endpoints and subtract them. All right, so let's try that. Okay, so let's go to the next page. All right, find the distance between the following coordinates on a number line. Okay, so negative 3 and 8. See, I'm not even giving you the number line. I can still do this. I always like to do the larger one first. So I'm going to do 8 minus negative 3, and its absolute value. So 8 minus negative 3 becomes 8 plus 3, which gives me 11. And if we think about that, from negative 3 to 0 is 3, and from 0 to 8, it's 8, so it's 11 units. All right, next one, 4 and negative 1. 4 minus negative 1, absolute value. 4 plus 1 gives me 5. All right. Negative 2 and 2. All right, this one's, I'm going to do 2.2. I always like to do the bigger one. Minus negative 2. Negative 2.2. Okay, that becomes plus. And again, always put those absolute values just so that we know our answer always has to be positive. So 2.2 plus 2.2 gives me a distance of 4.4. All right, 0 and negative 17. So if I do 0 minus negative 17, of course I take the opposite value, well that negative becomes positive, so my distance is 17. All right, I want you to try 12 and negative 1.5. We're going to get the answer, and so tomorrow I'm going to check your answers to make sure you guys really understand. Okay, moving on. All right, so then it should say for you, suppose. And I gave you a segment, and I gave you a segment here, 1 with A, B with 5, and C with 12. And suppose I said to you, find AC. That means I want to find the distance AC. Well, what you could do if you wanted to, from 1 to 5, 5 minus 1 is 4, so we know that this distance right here is 4, actually. I'm going to switch colors to black. Is 4, and then 5 to 12 is 7, right? So if I wanted to find the whole distance, could I do it in parts? Well then, if I wanted to find AC, I could do 4 plus 7, which is 11. Okay, so this is actually really interesting because think about what you just did, and now we're going to look at this example. So I gave you a segment, A, B, and C, and I said that this piece of the segment from A to B was X, and this piece of the segment was X plus 6, and then the whole segment was 24. Well, I can actually just take the two parts and add them together and set them equal to the whole. So x plus 6 is equal to 24. So it gives us an algebraic way of adding segments together, giving us the whole segment. All right, so now I'm going to solve. okay? So I'm going to add the like terms. X and X gives me 2X plus 6 equals 24. I'm going to balance my equation using that algebra. I'm going to get that 6 to the other side by doing its opposite operation, subtracting it to the other side. All right, so then I'm going to come up here. So 2X equals 18, and then I'm going to divide by 2. So then X equals 9. Well, X equals 9, that tells me that AB's segment is equal to 9, and then 9 plus 6 is 15, and 9 plus 15 does, in fact, give me 24. So this idea of adding segments together is actually something in geometry that we call the segment addition postulate. Okay, we've talked a little bit about postulates. Postulates are things that you accept to be true. And so if B is between A and C on a segment or on a line, if B is between A and C, then segment AB plus segment BC is equal to segment AC. So you can use the segment addition postulate to help you find missing values, to find the lengths of segments. The one thing you do have to note, and I put it down there as a note, is that B is not necessarily in the middle. It doesn't mean it's the midpoint, okay? So that's really, really important. Okay, so let's keep going. All right, we're going to practice. So I said if AB, and actually let's make these segments. Let's make these all segments. No, let's leave it. It's fine. So if AB equals 6x minus 1, BC equals 2x plus 7, and AC equals 30, solve for x. And I think I gave you a segment. That's why I need to write it. Okay, so I gave you a segment, A, B, C. Okay, so AB is 6x plus 1, so I'm going to label my diagram with what I'm given. I'm given that AB is equal to 6x minus 1. I'm given that BC is equal to 2x plus 7, so I'm going to label my diagram with it. And I'm given that the whole segment is 30. So I'm going to use the segment addition postulate that says the sum of these two parts equals the whole. All right, so then I'm going to add the segments together. So 6x minus 1 plus 2x plus 7 is equal to 30. Now I'm going to do that algebra that you know from last year. I'm going to combine the like terms. 6x and 2x gives you 8x. Negative 1 and 7 is going to give us a positive 6. That's going to be equal to 30. All right, give you a second to write this down. All right, so now we're going to subtract the 6, doing the opposite operation. Backwards PEMDAS is actually what we're doing. And then we get 8x equals 24. And I'm going to divide by 8. So x equals 3. All right, now I'm looking at it. I go back to my question. My question says solve for x. Oh, so I'm done. I've got my x. Yay. Okay, so let's move on to the next example. You have to be really careful with these because I'm going to ask you for different things. Sometimes I might just ask you for x. Sometimes I might ask you for a segment length. Sometimes I might ask you for the whole length. So always go back once you finish the problem and go, okay, what did she ask for? You should do that with everything. All right, so again, I gave you a segment. We're always going to label and mark our diagram with what's given. AB is equal to 6x. BC is equal to 2x plus 1. And AC is equal to 25. Okay, so what I want you to do is I want you to press pause. I want you to do the problem, and then I want you to come back and check your answer with me. So press pause. All right, so you've done the problem, and you got 6x plus 2x plus 1 equaled 25. You combined the like terms, you got 8x plus 1 equaled 25. You subtracted 1, so you got 8x equals 24, and x equaled 3. Wow, pretty darn close, huh? Okay, so then it asked to find BC. So you took x, you plugged it in, you substituted it in for x into x plus 1. So you would have gotten 2 times 3, which is 6, plus 1, which is 7. So BC is equal to 7, and there is your final answer. All right, moving on. Again, remember, you can pause at any time if I'm going too fast. All right, what does the word congruent mean? All right, so we talked about this. Congruent in math is going to be equal. It means equal. We're going to have congruent segments, and we might have congruent triangles, or we might have congruent polygons, okay? But congruent segments, so I would use that symbol for congruent, AB is congruent to BC. And remember, if I mark things congruent, I want to always use the hash marks that we talked about in an earlier lesson. All right, moving on. All right, so define bisector of a segment, aka the segment bisector. Okay, so another definition that we kind of have to go through. So a segment bisector is a point, line, or plane that divides a segment into two equal parts, or two congruent parts, okay? All right, so here's an example of a segment bisector. So here we've got a segment. I'm going to draw a line going through it like that, and I'm going to mark these two congruent. So this line is the segment bisector. It is cutting the segment into two equal parts, so I've actually put my hash marks indicating that. Okay, so this point right here, where that segment bisector is hitting that segment, that's actually the middle, okay, which we're going to talk about next. That point, that middle point, is called the midpoint, okay? So the definition of a midpoint. The midpoint is the middle of a segment, okay? But the definition and what we're going to be using is if M is the midpoint of segment AB, then AM, segment AM, is congruent to segment MB. Okay? All right, so let's draw that. Let's draw a picture here. I tell you that M is the midpoint of AB. All right, so the first thing I would do is then say to myself, okay, then AM is equal to MB. I'd mark my diagram with what I'm given. I'm given that M is the midpoint, so it's telling me these two segments are congruent, which means that they're equal. All right, so now let's use that to see if we can solve a problem. And actually, I don't really love this color, so I'm going to change the color because I can't see it that well. I'm getting old. That's a bit better. Okay, so our first example. Point M is the midpoint of VW. Or I didn't say that. Okay. Find the length of VM if VM and MW, or VM equals 4x minus 1 and MW equals 3x plus 3. Show all your work. Okay, so the first thing that I would do is I draw a segment, VW. And I put an M in the middle because it says point M is the midpoint. Okay? So that means I'm going to mark my diagram with my given using my hash marks. All right, so VM is 4x minus 1 and MW is 3x plus 3. If they both have the congruent hash marks, that means that they are equal. So in algebra, we can write an equation because they are equal. We can say that 4x minus 1 equals 3x plus 3. All right, so now we're going to use that algebra we like so much. So we're going to subtract 3x. We're going to add 1. And we're going to get x equals 4. All right, but it said find the length of VM. Okay, it wants us to find the length of VM. All right, so this is the length of VM that I want. I'm going to take 4. I'm going to substitute it in for the x, and I'll get 4 times 4 minus 1. So 16 minus 1 gives me 15. So VM equals 15. Okay? All right, so what we're going to do is we're going to actually, let me just see if I've got one more on here. Nope. Okay, so we're going to stop there. What I'm going to ask you to do is do the try now, where given segment JR is given, and M is the midpoint of JR. I'd like you to do that problem, and tomorrow that'll be the second problem that I'll check from your homework to see that you understand. We'll review a tiny little bit, and then we will get to work practicing all this, okay? All right, hope you had a great day. Bye.